Hello everyone and welcome back to my channel. My name is Piyush and this is another addition to the 40 days of Kubernetes series that we were running. Yes, it was supposed to be 40 days of Kubernetes that covers the entire CKA curriculum, which is Certified Kubernetes Administrator. But then recently CNCF introduced new changes, or we could say Linux Foundation introduced new changes to the exam, which compelled me to create this video and many videos after this. So in the previous video I have shown you what all the changes has been done recently on 18th February 2025, and based on that I'm expanding this series to have the latest details or latest topics that are included in the series. Okay, so in this particular video we'll be looking into Helm, which is a package manager for Kubernetes. We'll look into it from the theory perspective, what it is, why do we need it, important commands and so on, and then we'll do a demo as well to install a sample chart and to execute basically all the commands that is associated with Helm. So make sure you provide your support and your love by sharing the video, by hitting the like button, by commenting on it like you have always done. And without any further ado, let's start with the video. So if you can see at my screen, in this video we're gonna talk about Helm. Basically, what exactly is Helm? That's the main important question. And why do we need it? So Helm, as you can see, it's a package manager for Kubernetes. What is a package manager? Package manager is a utility, is something that helps you install software packages with ease. What do I mean by that? So let's say you are running on Windows, then Windows have its own package manager, like we have Choco, and then there are a few more. I'm not remembering the name, but if you have to install, let's say, some utility in Windows, you can just do Choco install this, Choco install that, right? Similarly, in macOS we have Brew, or it's also called Homebrew, which is also a package manager. In Ubuntu we have apt, so we do apt-get install, apt-get update and so on to install the package from a repository. And then in Red Hat we have yum package installer. So all these are nothing but the package managers for different operating system, and their main purpose is to install a particular piece of software or install a particular utility. That's, but it also helps you do that with ease, do that with minimum configuration changes, do that to by performing minimum steps, so that you don't have to go to the official repository or official download page, download the binary and make the changes yourself. You can just install the package with a single command with the help of package manager. So Helm is a similar tool but for Kubernetes. Like, why do we need it? Okay, so let's understand why do we actually need it. So let's suppose you have to install a tool called Argo CD. Okay, we're not getting into the specifics of Argo CD in this video, but let's say we have a tool, we have a CI CD or GitOps tool called Argo CD that we have to install. The normal process is you download the binaries from the official site, and then you follow the further instructions like do this, run this command, and then make these changes and so on. So it's a list of commands that you need to perform. And if you install Argo CD as a pod in Kubernetes, so that means what you will be doing, you will be downloading separate files. It will be a folder, it will be a GitHub repo from where you will download all the separate files. And then these files could be deployment YAML, service YAML, role binding, policies, namespace, secrets, config maps. There could be hundreds of files per project or per utility that you want to install. And if you are doing it manually, that means you have to manage each of the files manually. You have to make each change, the change that you are making, you have to make the change manually in all those files, unless you are using a CI/CD tool or unless you have created an end-to-end pipeline to take care of it. But it's a tedious task. It's not worth spending time on, right? So that is where Helm come into the picture. Okay, what it does, it actually bundles all those files together. So let's suppose this is a zip or an archive of all these files together, and collectively we call it a chart or a Helm chart. Now instead of downloading and maintaining these files separately, what it does, so Argo CD, let's say Argo CD created a chart of all these files, okay, with all the dependencies and everything. And then they stored this chart on a repository, a Helm repository. Helm repository you can check from this URL, artifacthub.io. Okay, this is where all the charts reside, all the companies, all the tools, they actually create their charts, the Helm charts, and upload it to a central repository which is called artifacthub.io. Okay, there you can locate all the charts, there you can search the charts and so on. This is like a GitHub but for charts. Okay, now when you have to, let's say, install this package, you can just pull the chart from the repository and create a release out of it. Release is a running instance of the chart. Okay, so when you, let's say, let's take the example of Docker. A Docker file can be considered as a chart which has set of instructions, which has what needs to be done. But when you actually create a container from a chart, okay, it becomes a running instance of the Docker image, right? Similarly, in Helm chart, a chart is nothing but a package, a bundle of files, and when you actually execute that chart, you will get a release, which is a running instance of the chart. Okay, so it will be more clear when we see the demo, when we understand it with the help of hands-on demo. But for now, just understand Helm has these three main parts. One is a chart, like it has other components as well, but these three are the main pieces that we put together in Helm. So we have a chart. Chart has a format, chart has a folder structure. I'll walk you through all those things. And then we have a repository where you can upload or publish your charts, or where you can download the existing charts from. And then you have a release, so there could be multiple releases of the same chart. Okay, so charts are reusable. That means a single chart can be deployed into multiple environments, and each time you deploy a chart, a new release is created. Okay, now you can search and use existing chart from the Helm repository. That's the main theory part of what a Helm is, how it works, and all these different components. Now let's dig into the demo and let's see it in the action. So for this demo, I'll be using Code Cloud's Playground because it already has the cluster installation, and like I don't have to do it all over again because I did it when I released the playlist, but then it's been a long time and I have to set up everything again. If you have a running cluster, feel free to use anything that you like, or if you have the subscription of Code Cloud, then you can use that as well. So it's up to you. It's not a sponsored video, it's something that I'm using because it's convenient for me. Okay, and I have actually explained multiple times the end-to-end installation of Kubernetes cluster upgrade and all the related tasks. So if you can follow those videos as well, you should be able to install everything. So there is a day 6 video in which we install Kubernetes cluster using Kind, day 27 video in which we have installed Kubernetes cluster, a multi-node Kubernetes cluster using kubeadm. So this is a similar setup. So if you can check kubectl get nodes. Okay, I have a 3 node cluster running version 1.30.0 of K3s, and which is a lightweight distribution of Kubernetes, and it has one master node and two worker nodes. So that's all we need. So first thing we're gonna do is install Helm. Okay, so let's go over here and let's just Google install Helm. Okay, this is the first official link from helm.sh, and like any other software, it has different ways you can install Helm. So from the release binary, or from this particular script, or through package managers, like we have discussed a little about package manager, right? So let's use the package manager. So for apt or Ubuntu, we can use this command. So what it will do, it will download the Helm repo, and then it will download actually the keyrings for this particular repo. Then it will install the related dependencies, https certificates, and then it will sign those certificates. It's like a self signing that it will do, and then it will update the repo, the local repo, and then it will install the Helm chart, okay, from the official repo. So I'm just gonna copy everything and let's go back. over here and just paste it over here. Okay, so it's gonna do the apt-get update and then it will install the package. Okay, apt-get install Helm. All right, so if I just gonna do Helm version now, which Helm installed in this directory, but it is by default looking in this directory. So what we can do is we can just copy sudo copy this to this. You might not face this issue, but if you face, you can do this. And now if you do which Helm, it's good. And then if I do Helm version, it's showing me the version. So it's 3.17.1. That's the latest Helm version. I believe that's one of the latest Helm version. And now let me just clear the screen and run helm hyphen hyphen help. Now this will show you all the commands that Helm comes with. So we'll like it won't be possible to look at all the commands, but we'll be looking into the important commands. So for the starter, let's use this command to create a new chart with a given name. Okay, so if I'm gonna do helm create and let's do hyphen hyphen help again, it will show you all the sub commands as well. So the usage is helm create and the name of the chart. So it will create a chart with the default folder structure with the empty files or with the default values. Okay, so let's run that command. I'm gonna clear the screen one more time and come on, clear. Okay, helm create and then the name, let's call it sample chart. Okay, once I do that, it says creating sample chart, and let's do an ls over here. There's a folder sample chart. Let's cd into the folder, and inside that we have different files. Okay, so two files and two folders. Let's look into all of these. So if I do find over here, you will see the folder structure, or if I do tree over here, this would be better. Tree command is not over here, so let's anyways. Okay, so let's look at this. So we have a folder called charts and we have a folder called templates. In templates, there will be all the templates that we can use for the chart, right? We have a service account, we have HPA deployment, and then it has some unit test cases. Inside that, then there'll be ingress services. So a few sample, like it could be, there could be config map, there could be secret and so on, right? And then in values.yaml, in fact, let me show you the values.yaml as well. In values.yaml, what it will have some values in a YAML format. It's a YAML, but it's in a key value format sort of, right? So for example, replica count is 1. I will show you how it's used. And then it has image repository value is nginx. Now if I go back, okay, so let's open this deployment YAML over here. This deployment YAML is not something that you would see in the normal Kubernetes, right? In Kubernetes you have the same format like API version, kind, metadata, spec, everything is same. Instead, the values over here are parameterized, or it's called templated, whatever you want to call it, right? So the value is actually, this is just a reference, and the value is getting picked from somewhere else. Like there are different sources of the values, but it is picked from somewhere else. What's the main advantage of it? The main advantage of this is you don't have to make any changes in the YAML file. So deployment YAML, service YAML, ingress, config map, secret, you don't have to make any changes in those files. Rather, you have to only make the changes as per your needs, as per your customization in those files from where the values are getting picked from. We'll have a look at those files. So there are different sources. For example, let's say over here, replicas. The replica value is values dot replica count. Okay, that means this field replica count is getting picked from a file called values.yaml. Okay, because dot we are accessing dot values from values.yaml. If this is, let's say, include sample chart dot full name. Okay, so this is, we are referring from the chart name dot a variable. So this is coming from a helper, the default helper.template file. I will show you that as well. And we can have other sources as well. For example, we can pick the values from the release name as well. We can pick the values from different other sources. Okay, so let's close this and let me show you those sources as well. So helper.tpl, this is a template file from where the values is getting picked. For example, over there we saw full name, right? So you can search the full name over here. You see, it's calling a function called values. If the values.yaml has a full name override, that means values.yaml and then truncate to 63 characters and then trim the suffix, else create this. There's a simple commands that they are running over here to generate the value of a variable. Similarly, we have different, if you go down you will see there are labels. Okay, so again, labels they are generating over here. Then if the chart dot app version, they are checking if it is defined, then make sure that you have a label app.kubernetes.io/version with the chart version. Remove the quotes. Okay, so that's what they are doing over here as well. And if you go back to deployment.yaml, so you see this include sample chart.yaml. So anything that starts with your chart name, it is coming from the template file, the helper.template file. Anything that comes start with values, it is coming from values.yaml. And anything, does it have release, so you can pull the value from the release metadata as well, like release name, release version, and so on. And then you have dot chart, that means it is coming from chart.yaml. So if I go back and if I open this chart.yaml, right, you see there is these things, type, version, app versions, and all those things. So these are coming from the chart.yaml. So there are two different versions over here. One version is the chart version and one version is the app version. Chart version is the version of the chart bundled together. That means whenever you make any changes to the chart itself, you will increment this version. Okay, but whenever you make any changes to the application itself, then you increment this version. So there are different versions over here, and the version semantics can be used like what we have in Kubernetes. If there is any patch changes or a bug fixes, you can update the last field. If there is any small release, you can update this field, the middle one. If there is any major release, you can update the first one. Okay, so you can follow the same semantics over here as well. And so we have deployment.yaml, chart.yaml, and then we have values.yaml. Where is values? Okay, over here. If I open this, so over here you see replica count has been specified as 1 over here. So that means in deployment we can refer this value from dot values dot replica count. Okay, and we don't have to make the changes in those YAML files. We can just make the changes in these reference variables, and we can use this in multiple places. Like we can use the same chart to deploy in multiple environments by just changing these values or making the copies of these YAML files, not the actual deployment YAML files, but these reference or config YAML files that we can call. Okay, so that's the overall structure of a Helm chart, of a sample Helm chart. Now let's see what we can do if we have to install a particular application using a Helm chart. Let's say Argo CD. Okay, so for example, Argo CD, we're trying to install that. So what you can do, there are multiple options. What you can do is you can go to Artifacts Hub. Okay, artifacthub.io. Okay, so this is, as I've told you, the GitHub repository for Helm charts. So you can search your package over here. You see there are 16,000 plus packages and these many releases have been done. You can browse all packages or you can search from there. So these are the most popular packages. This is Prometheus Stack, Cert Manager, Ingress, Nginx, Just Prometheus, Redis, Argo CD, and so on. Okay, so let's try to install this package, or you can search from here as well. Make sure you download and install the official package. You can search the filter from here. So official and verified publisher. All right. So let's say this one. So click over there and click on install. Okay, so these are the commands that you need to execute. First is you need to add the repo to your local repository and then install from the repo. So just copy this command and go back. Let me clear the screen. Helm repo add. Argo has been added to the repositories, and then the install command. Okay, so this will create, the format is Helm install and the release name. So my Argo CD is the release name, and this is the repo and the chart name. Okay, and this is the version, the optional fields that we have. So using this, you can install a package, an Argo CD package to your cluster. Okay, this is what it says. It says it's been deployed and the namespace is default. You can run the kubectl port forwarding to forward the port and then open the browser. So let's check over here. Let's run this command, and then it's forwarding for 28080. Now if you run this command on this, but it has to be inside the lab environment. So let me open okay, let's open any. Okay, I don't think it will work like this because I'm inside this. Anyways, I mean, this is how we install it. You can, if you have a cluster installation done, you can check it on your particular node IP wherever it is running. But this is what we need to do to install Argo CD or any other chart. Now you can run basically different commands. So I'm just gonna close this. So now you can run different commands to check the versions, to check the releases and so on. So if I can just clear the screen and run Helm list. Okay, so this will, let me just remove this. How? Okay, so this will show you the different releases that you have in place. So I only have one release, which is my Argo CD in the default namespace. Revision is one because I have not made any changes. Whenever I make any changes, this will create a new revision. Okay, status is deployed, and this is the app version. So all the metadata, and this is the chart. Argo CD 7.8.10. This is the version. Okay, so this is the chart version, and this is the app version, both the things. Okay, and this is how you can check the releases that you have deployed in your cluster. Now what we can do is we can also upgrade the Helm chart to a different version. So for that, you can run the command Helm upgrade. Okay, and then let's say the release name. Okay, and then the chart name. Chart name was, what was the chart name for Argo CD? It was this. Okay, I believe it won't do anything for now because we are already at the latest version. But this upgrade command is something you can use to upgrade your chart to a newer version. So it should upgrade this chart version if we were using a older version over here. Okay. So what does it says? Chart has been upgraded, and if I do a list again, it does not upgraded the version, but it has created a new revision because we made some changes to the chart. Okay, and you can also, what you can do is you can pull this as well. So if I do Helm pull and mm, argo cd. Okay, so what I did, do a ls over here, and you will see there is a tar file that was downloaded. So it downloaded the Helm chart of Argo CD in a tar file. If I do tar xvf to extract it, okay, it has extracted everything. You see, these are the files that it has. It has a lot of templates, and then it has values.yaml, chart.yaml. So if I do a vi on values.yaml of Redis, or there is the values.yaml for Redis, or there should be for the front end service as well. There are so many changes that you can do you can customize it as per your needs. Let's use this. Okay, so let's do a vi on this. Okay, and this is much more complex than what we saw, but it is basically doing the same thing. It is using some inbuilt function of merge, overwrite, and copy. What it is doing, it is copying the value from values.yaml. Inside that there'll be a global parameter, and inside global there is a sub parameter called deployment annotation, and similarly it is taking the values from different things. There are some inbuilt function that it used, but it is too advanced for this particular video, so I'm gonna skip that part. But this is how it is taking the values. And then if I check the values.yaml, any values.yaml, let's take this. This should have your customization, like this is the particular tag that you should be using, this is the repository from a redis image, and all those values, this can be referred over here. So you can make the changes over here and then use this particular folder to install the chart for you. Okay, instead of providing, so the command that we were using install earlier, it was this one, right? So instead of providing this repo argo cd, you can just do a dot slash, so it will check the repo in the current directory and it will install the chart for you, and version you can define as per you. Okay, so that's another command that you can check. And then if you want to roll back any changes, so let's say you want to roll back the latest chart. Okay, clear. Okay, so helm rollback, and what was the name of the release name was so the chart name was my argo cd. It will roll back the chart for you. Okay, it says rollback was successful, so helm list. Okay, it created a new revision and it rolled back the changes, but it's still app version is 2.14.5. Maybe it was something else earlier. Okay, but anyways, it rolled back the changes. That's what it said, and that's what you want to know. And there is another important command called helm search. With helm search you can search in either the repo or the hub. Okay, so let's do a helm search hub and search for argo. You will see all of these different argo charts that are available, some of them from the official repository, some of them from some other private repositories, like that is made public. And you can just search, let's call it argo cd. Okay, no results was found. So if we go back and see, the official repository is argo slash argo hyphen cd. Actually the repository is argo cd. So let's go back and remove this. Okay, now you have these many results. Where is the official one? I believe this is the official one, right? It's at 7.10.02.1.5. Yeah, this is the official one. Helm argo cd and something something. So you can search it from here as well, and you can search instead of the hub, you can search in the repo. So let's search in the repo argo. Okay, so there is this argo repo as well, and this is the official one. Okay, and this is also official, but it's not the argo cd product. It's something else for argo workflow. Similarly, we have argo ci workflows, rollout, different image updaters, different product from argos, right? So this is from the official repo. Okay, I believe this is all the things that we wanted to check. I believe this should be sufficient for the exam and from the beginner's perspective. So I hope you have a good learning experience. I hope you found it helpful, and make sure you try it out yourself. Only then you should be able to make the best use of it. So thank you so much for watching. I will see you soon with the next video, which will be about customize. Thank you so much.